Large, unified multimodal models are increasingly prevalent, promising to understand and generate across diverse modalities like images, text, and audio. The core assumption is that understanding the input properly informs the generation process, leading to coherent and insightful outputs. But is this actually true? Are these models genuinely reasoning and transferring knowledge, or just cleverly stitching together patterns learned from massive datasets? This paper digs into this very question. The crucial insight is that existing datasets are often leaky. Models might cheat by memorizing patterns directly linking input and output, rather than truly understanding and reasoning. To address this, the authors introduce UniSandbox, a decoupled evaluation framework. Think of it as a controlled laboratory environment where they can precisely manipulate the input data and observe how it affects the model's reasoning and generation abilities. This allows them to isolate and study the understanding generation gap in a way that's not possible with real-world datasets. The paper focuses on two key dimensions. First, reasoning generation. Can the model solve tasks that require multi-step inference based on the input? Second, knowledge transfer. Can the model learn new information and effectively use it during generation? For reasoning, they find that vanilla models struggle, but performance improves significantly with explicit chain of thought, COT. COT involves generating intermediate reasoning steps before the final answer. For knowledge transfer, they observe that COT again helps, by guiding the retrieval of relevant knowledge. They also found that query-based architectures, by their nature, seem to perform latent reasoning, even without explicit COT. The results are quite revealing. UniSandbox demonstrates that understanding doesn't automatically translate to good generation in current models. The paper provides strong evidence that explicit reasoning, especially through chain of thought, is crucial. Moreover, the latent reasoning capabilities of query-based architectures offer a promising avenue for future research. This work highlights the importance of designing architectures and training strategies that explicitly bridge the understanding generation gap. It paves the way for more robust and trustworthy multimodal AI systems that genuinely understand and reason, rather than simply regurgitating memorized patterns.